Here we go, yet another function toolkit equation here, another graph. And once again, we have logs involving e's. So just prepare yourself mentally for this one, or not. All right, we can insert a SpongeBob meme of SpongeBob being exhausted and leaning against the wall. I should have put that meme in here. But anyway, that might be a copyright thing. So let's just move right along to some actual math. All right, here we go. Okay, so first of all, the natural log function right here looks like this. Okay, it is still an exponential function with key point at 0, 1, and a vertical asymptote at x is equal to 0. That much hasn't changed. This is still a log function like the previous example. The only difference is the subscript number would be e, which we'll see in just a few minutes. So let's do a mapping notation right here. Okay, we can get the mapping by doing x plus 5 and 3y minus 3. And we know our vertical asymptote is our horizontal translation. And we can do a key point of 1, 0. And I realize already I made a mistake here. Okay, let's go back to the right over here. This was a mistake. Should be 1, 0. Not going to delete. Going to continue with this video. Let's do it. All right, plugging in numbers here, we're going to have 6 and -3 as our KP, the key point. And we have a vertical asymptote of x is equal to 5. Let's put all of that in right now. So we have something like this. Have our vertical asymptote in. We have our key point of 6, -3. And here, okay, it looks like it's not even going to have a y-intercept. But we'll deal with that in a second, okay? We could sketch the graph right now. There are no reflections. Or you could wait and get your x-intercepts first, okay? So again, maybe we'll do all that first. So we can get a y-intercept by plugging in 0 for x. If there is a y-intercept, you'll see in a second how you can tell that there is not. First of all, you can look at the actual graph and you know it's going to come up like this somehow. We might fine-tune that in a second, but clearly it doesn't intersect the y-axis. So you might just see it from the graph alone and not even have to calculate. You can say no y-intercept. Or if you didn't recognize that and you tried to do the algebra, okay, what would happen is you'd end up putting in 0 for x, and then you'd run into a problem here because you end up with the natural log of a negative number, and this is a problem right here. You can't get the log of a negative number. It doesn't exist. So in this case, okay, we would just say no y-intercept. So you could either discover there's no y-intercept from the graph. You can see visually it's not going to intersect. Or you could see using algebra that it's not going to work either. Let's try for an x-intercept. There definitely is an x-intercept. So we're going to plug in 0 for y. And we're going to do all this right here. We're going to try to isolate the x as much as possible. And then here, okay, we can divide both sides by 3. So you end up with 1 is equal to the ln of x minus 5. And from here, okay, what we can do is we can change ln to log subscript e. Remember that e is like pi. It's an actual numerical value. It's at 2.718 something or other, okay, and it just goes on to infinity, much like pi. But you hear pi in popular culture all the time. You don't ever hear about e, all right, unfortunately. But we're going to change things with that, all right? We're going to get into e mode right now by changing this to an exponential function. E to the power of 1 is equal to x minus 5. And then e to the 1 is just e. Bring over the minus 5. And from here, okay, your calculator can take care of the rest. Okay, you can get a solution right here. And that's going to be approximately 7.718. And that is our x-intercept. So we can go back and we can plug that in, which looks like we were pretty much on track already. And we have our graph drawn. Now we just need to do our domain and our range For any log graph, we don't have to think about the range. It's always all real numbers. And in this case, okay, you can see that for the domain, it begins with -5 and ends at infinity from the left and right. And there we go. There we have completed our fourth and final log and exponential example. And away we go. Now it's time for you guys to try some problems out.